Hi, welcome again to the lecture on future value of a single cash flow. In our previous lectures, we have discussed about the time value of money. That means the importance of timing in valuing the cash flows. We have also discussed about the rate of compensation needed for delaying cash flow, which we call interest rate. And there are two types of interest rates: simple rate and compound rate. And I want to remind you again that from now on we will be using only compound rate, because this is the rate that is normally used in the real world. Okay, so in this lecture, at first I will of course show you the notations that will be used, and we'll try to find the future value of a present amount of cash flow for different duration, like 1 year, 2 year, as an example. And based on that, we'll try to come up with a general formula so that we can find the future value for any future time period. And at last, we'll try to see a very simple example of applying that formula. Okay, so let's begin. At first, the notations. Only one I will change only one notation. Other notations are the same. I will use R to indicate the compound interest rate, so that we can at least differentiate with what we have used before. So R is the compound interest rate, normally mentioned as a percentage per year. N is the number of years. Okay, we have considered year as a standard period unless otherwise stated. And PV is the present value or present amount of cash flow that we may pay or we may receive. And FVN is the future value in N years. Okay, so if we get the value of N at first, then we also know what is the time of the future value represented by FVN. For example, if N is equals to 10, then FV10 means the future value after 10 years. So this is all about the notations. Now let us try to recall that the future value is actually the present value plus the interest on both principal and interest, previously earned interest. So if we consider that the interest is paid every year, interest should be given every year, then for calculating the future value in 1 year, we may not have the interest on interest part. Okay, so now let us try to find what should be the expression for future value after 1 year. Okay, so using the previous notations, the future value after 1 year should be FV1 equals to the present value plus the interest on the principal. And as I have said, because this is the future value for only 1 year duration, so we do not have any previously earned interest, therefore we do not have interest on interest. Okay, so if we look carefully, we have two PVs in this expression, which can be considered as a common factor. Okay, so if we do that, then our expression becomes FV1 equals PV times 1 plus R. So we have to multiply by 1 plus R with the present value to get the future value. So future value certainly will be a higher amount than the present value. So now let us try to find out the future value after 2 years. For 2 years, now the notation for the future value will be FV2. So in that case, the FV2 should be equals to, okay, now we are not starting from PV, we are starting from FV1. Okay, so if FV1 is the value in year 1, then FV2 is the value in year 2. So we are also calculating, in this case also we are calculating the future value for 1 year duration starting from FV1. Therefore, we have FV1, the amount at the end of year 1, plus the interest earned on that amount during the second year. That means starting from the end of year 1 until the end of year 2. Okay, this is why our expression is like this: FV1 plus the interest FV1 times the rate of interest per year. So here we can see that FV1 is the common factor. Okay, so therefore taking it as a common factor, our expression reduces to FV2 equals FV1 times 1 plus R. Now now of course you remember that in the previous slide we have already shown that FV1 is in terms of PV. Actually our intention is to express any future value in terms of the present value of our cash flow. Therefore we will always try to replace it with present value, with the expression with present value. So previously we have seen that FV1 is equals to PV times 1 plus R. Therefore we can replace this FV1 by this PV times 1 plus R. So if we do so, then we get that FV2 is equals to PV1 plus R, which is replacing this FV1, okay, and another 1 plus R came from the previous previous expression, okay. So now you can see that we have two 1 plus R. So if you multiply two same things, then we can express it using the exponent, okay. That means 1 plus R to the power 2, because we are multiplying same two things, okay. So FV2 will be equals to present value times 1 plus R square, or to the power 2. Okay, now let us see the future value after 3 years. Don't worry, that will be the last. Okay, so the future value after 3 years will be FV3. Again, we will do it for 1 year. That means starting from the future value in year 2. Okay, so it is FV2 plus interest, FV2 times R for 1 year, one year interest. Okay, here you can also see that the common factor is FV2. So I'm going quickly. Okay, FV3 is equals to FV2 times 1 plus R. Okay, so now I think some of you, you can guess what I'm going to do, because I have said that our intention is to express the future value in terms of present value. So again, from the previous calculation we have found that FV2 is equals to PV times 1 plus R to the power 2. So we can actually replace this FV2 with this one. Okay, so to do that, okay, we can, after doing that, we have found that FV3 is equals to PV times 1 plus R square, and this 1 plus R. Okay, so now you can see we have 1 plus R square times 1 plus R. That means we are multiplying 3 1 plus R's. Okay, 1 plus R times 1 plus R. This is for 1 plus R square. Okay, now, and we have another 1 plus R. So we have 3 here. Okay, therefore the power will be, the exponent will be 3. Okay, so FV3 is equals to PV times 1 plus R to the power 3. So you can see that we have successfully expressed the future value after 3 years in terms of the present amount of cash flow. Okay, and present amount of cash flow, and the interest rate, and also the number of years, which is 3 in this case. Now if we look carefully, the expressions for future value after 1 year, future value after 2 years, future value after 3 years carefully, then we will see a trend. Okay, so you can see that future value after 1 year is PV times 1 plus R. Future value after 2 years is PV times 1 plus R to the power 2. Future value after 3 years is PV times 1 plus R to the power 3. So can you see the changes? Okay, the changes is here, because we do not have anything as a power, as an exponent. Actually it is 1, you know that, right? So if it is future value after 1 year, then the exponent is 1. If it is a future value after 2 years, then the exponent is also 2. If it is the future value after 3 years, then the exponent is also 3. So we can understand that if the future value, if we want to calculate the future value after 50 years, then perhaps this exponent will be 50. Okay, so we can do it for the whole day, but it is not necessary. It is easily understandable that even if we continue, okay, we can come up with the general formula that future value after n year is equals to present value times 1 plus R to the power n, because it is the future value after n year. This formula can be used for finding the future value of a present amount of cash flow for any duration. That means for any value of n. Let us try to visualize it using the cash flow timeline that we have discussed before. So in this timeline, you can see that this PV is representing the present amount of cash flow that we have. Okay, now if we want to find out the future value after n years, okay, we can use this formula straightforward. Okay, so if we know the present value, that means this one, if we know the interest rate, and if we know the value of n, okay, then we can calculate this. So the value of n can be any value. It can be 2, it can be 3, it can be 1, okay, or it can be any value like 50 years or 500 years, whatever. Okay, so you can find the future value of your present amount of cash flow. Now let me add with this that the process of finding the future value from a present cash flow is called compounding. Okay, so if you calculate the future value after 1 year, or if you calculate the future value after 2 years, or if you calculate the future value after 50 years, okay, this process is called compounding. So in the compounding process, what we do is we multiply the present amount, because we know that if we want to be compensated for delaying our cash flow into future, then it must be higher amount. So to make it higher, we multiply with 1 plus r to the power n. The process of finding the future value in this way is called compounding. Now let us try to see an example. Present value is 100, for example, and the interest rate is 10%. Now what is the future value? Let's say after 10 years. So we can say that n is equals to 10 years. Okay, now we know the formula is FVN is equals to PV times 1 plus r to the power n. Okay, so using this formula, we can plug in the values. The future value after 10 years will be equals to PV is $100 times 1 plus r, that means 1 plus 10%. Now what I prefer is to write it in a decimal format when I do it on paper. Okay, so I'm writing 0.10, which is equal to 10%, to the power n. N is 10 because it is 10 year. From here we can find that $100 times 1.10 to the power 10 is equals to 100 times, now I need a calculator. I have already done it in the calculator. So the value is 2.5937. This is the value of 1.1 to the power 10. Okay, so we can see that the future value after 10 year will be $2. Okay, $259.37. Therefore, the future value of our present $100 after 10 year is $259.37 if the rate of interest is 10%. Now if the rate of interest is higher, then of course this value will be higher, because you know that we will be multiplying with a higher amount. So let us try to visualize again using the cash flow timeline. So in this case our present value is $100, okay, and we are trying to find out the future value after 10 years. So let me write 10 here. Okay, so after 10 year the value will be, after the compounding, okay, we found that the future value after 10 year is $259.37. I hope that you have understood how we can find the future value of a single cash flow using the formula FVN equals PV times 1 plus r to the power n. Okay, thank you very much for attending the class. See you again.